This is a new chapter. It's about fluid mechanics. The chapter contains topics about fluid mechanics, which include Bernoulli's equation of continuity and Archimedes' principle. So to start with, in physics, fluid is a substance that continuously deforms flows under unapplied shear stress or external force. Fluids are a phase of matter and includes liquids and gases. Fluid mechanics is a branch of physics. It's one branch of physics. Concerned with mechanics of fluid in motion, fluid dynamics, or at rest. It's called fluid statics. You see that fluid dynamics and fluid statics are two different things. The first one is deal about the motion of fluid. The second one deal about fluid at rest. And the forces with them. So the study area is with many diversified problems such as surface tension, fluid statics, flow in closed body or flow around bodies, solid or otherwise, flow stability. The application of fluid mechanics are enormous, and we can see that the fluid mechanics can be applied in breathing, medical application, blood flow, swimming, pumps, fans, turbines, airplanes, ship, rivers, so many things, including pipes, windmills, engines, icebergs, filters, jets, so many things are included under the application of fluid. So now let's start the first subtitle, which is 3.1. It's all about properties of bulk matter. Before that, we have to see the difference between plastic material and elastic materials. Now we can see the elastic materials are materials that regain their original shape and size. So after some elongation, we apply a force on this elastic material, and if you release or if you remove the force that's applied on the elastic materials, then you will get the original shape in case of elastic material. When you see the plastic materials, they do not regain. When you see this do not regain, but for elastic materials they regain their original shape as well as size. But when you see the plastic materials, they do not regain original shape as well as size when deforming force is removed, or the applied force on these materials is removed. That is the difference between elastic and plastic materials. The other thing that we see is elastic deformation is reversible deformation by a force applied within the elastic limit. Beyond the elastic limit, a force applied on an object causes permanent or irreversible deformation called plastic deformation. This type of deformation is reversible deformation that can be seen in different materials. And the other one is elastic properties of solid materials are described in terms of stress and strain. The following shows how this stress and strain are important. Before that, it's better to define what stress means and what stress means. Stress is a force per unit area, and when you simply define strain is change in configuration divided by initial configuration. So when you see the unit, the force is measured in Newton and area is measured in meter square. This area is measured in meter square. The force is measured in Newton, so stress is equal to Newton per meter square, which is the expression of the unit of stress. Whereas strain, the change in configuration and initial configuration. So measures the amount of deformation by applied stress and defined as the change in configuration of a body divided by initial configuration of a body. it's possible to explain more with some examples. So now, as you can see, different points of materials. This strain can drawn like this. The y-axis express strain, or we can list the different data of stress in the y-axis, and the data on the x-axis explains about strain. So different data can be listed, can be collected from the different instruments. Okay, so you can see there is a material which is called plastic material. So with a small amount of stress, we can get a very large amount of strain. So with a small amount, we can get, with a small amount of stress, which is force over area, we can get a very large amount of strain. So we have a long elongation. Then between, the other one is brittle material. In between we have ductile material. So brittle materials, small strain is obtained with a large amount of stress. So the increase in stress is larger as we compare to the increase in strain. So these type of materials are called brittle materials. In case of iron, they are considered to be